So I think the first thing to understand is the dynamic has shifted in the industry. 20 years ago, 80% of the cost of remanufacturing an engine was the engineering cost, 20% was the parts. Today it's the opposite. 20% of the cost is our engineering and the 80% is the parts. So we need to change the buyer's mindset in driving down their cost and looking at cost saving. The cost saving is not made in cutting costs on your engineering. The cost saving can be made on the 80% side of things. By cost saving on engineering, what we're trying to do here is remanufacture a component to the OEM standard and specification. Anything that a customer chooses not to do in order to cut costs is going to jeopardize longevity of the component that's been remanufactured. It's not a smart move. So if we start with repair can be termed as fix or fix as fail. There's another terminology that's used in industry. That is basically taking an engine as a complete component and just repairing what is needed. So it is not remanufacturing each component to specification. It's just fixing what needs to be done. It's often put together reusing parts, and as such, it's not a complete zero-hour rebuild, which is what remanufacturing is. Remanufacturing is taking all the components back to original OEM specification and fitting it with new parts, gasket seals, all of those good things, and putting the engine together so you could put it side by side with a brand new engine and you can expect the same life cycle. It's a very, very scary scenario. We're already down that road with passenger vehicle and light commercial vehicles on their engines. Nobody really overhauls those sort of engines anymore because the cost is too high and there's a market full of cheap imported second-hand units, and that's where the market's gone. As a result, those skills have been lost. It's starting to creep into the heavy diesel side too. It's dangerous because people are not aware. The price looks good, but you have no idea on the quality, what's in that engine, and how does the warranty work when something's come from overseas. Often stuff gets dumped on Africa, so there's that cost. The knock-on effect too is if we stop remanufacturing engines locally, we're going to lose the capacity to do it. We're going to lose the skills to assemble, to diagnose, to service in the field. And as a result of all of that, we're going to become dependent on importing. And once that capacity and those skills are lost in the country, it's very difficult to get them back. We're at the mercy of the rand dollar and whoever we're importing from. Buyers need to have a look. Obviously, the first thing that they look at is capital expenditure and what is that piece of plant going to cost. But you cannot base your decision just on that price alone. You need to look further down the line. And the reason for that is those pieces of plant, their transmissions, their engines in our case, are designed to be remanufactured several times. If you're going to buy on the bottom end of the market and buy on price alone, there's a good chance that your operating costs, your maintenance costs in it are going to catch you. And the reason for that is there's obviously a quality difference. So the durability of the construction, the availability of parts, the availability of service technicians and skill level, all of those things will jeopardize longevity of an engine. Whereas if you go with a premium product, your expectation can be that it's better quality, there's better product support, more parts availability, and all of those things talk to what are your big costs in operating. It's going to be availability. You'll need your plant to be available. If your machine is standing because there's no technician to work on it or there are no parts available, that's costing you money. Time is gone. You'll never make it back. So you need to factor that in. When you look at those engines, when they come to the end of their first or second life cycles, the buyers need to look at the industry standard is 80% of new. So if you send an engine in for remanufacture on its first or second life cycle, which would be a zero-hour rebuild, you would hope that the price would come in at about 80% of new. Anything over that, financially, the bean counters will tell you it's not viable, you need to replace it with a new. But if you can keep your remanufacture cost on a component below 80% of new, it should be viable for those first 2 or 3 life cycles of the complete plant. If we're looking at a dozer, you're looking at the complete dozer, so you have to take into account it's got an engine, it's got a transmission, it's got a fuel system, it's got hydraulics, all of those things. Those things wear as with the engine. So it makes no sense where you've got a dozer that's got 30,000 hours on, every other system is tired, to go and remanufacture an engine to 0 hour, because it's going to be hell of expensive. B, you're going to put it into a piece of capital equipment that the book value is probably less than the cost of the remanufactured engine. So there, you need to draw a line. If we look at locomotives, their design for locomotive life is 50 to 60 years, and the engines have been designed along those same lines. So they have longevity built into them. They have put enough meat for us to be able to remanufacture those engines enough times to see out the life of the locomotive. Metric has the capabilities to salvage those components that have been possibly over-machined in previous lives and bring them back to the OEM specification. So with regards to the components that come through the shop, every single component that comes through a shop, as per our ISO system, is identified, which allows us to track and trace every component. So we can build up a history on those components. When they come in for a second, third, fifth life on a locomotive, we will have seen it before, we'll understand what we've done, we know where we need to go and what we need to look out for. On a locomotive, the life cycles of the engine are fairly extended. You need to see full value on that remanufacture. So cutting corners on the engineering and not giving yourself a good foundation to build an engine on is not going to allow you to get to the full life cycle of that engine. So it's imperative that the guys are looking, whoever's remanufacturing those locomotive engines, are making sure that the engineering work that is done to OEM specification and complete, not just doing 1 or 2 items that they're comfortable with doing and leaving stuff off, which is a little bit of a habit at the moment, and we need to break that mindset in our industry. Just because we haven't done it in the past doesn't mean it doesn't need to be done. We need to remanufacture components to OEM specification, not to what we're comfortable with doing, if you want to see full service life.